Good morning, friend. This is Ravi Shankar. Here, I'm teach you network theory, and this is my second lecture. Here we will discuss about the circuit element. To very first, we have to know about the element. What is element? An element is the basic building block of a circuit. Okay, an element is basic building block of a circuit. There is two types of element found in electrical circuit. Okay, there first is passive element. Passive element are that type of element which cannot generate energy. Example are resistor, inductor, and capacitor. It can dissipate energy or absorb energy. In case of resistor, this is a dissipating element. It can dissipate energy, and inductor this can store energy, and capacitor also can store energy. And second element is active element. It can generate energy. Example are voltage source or current source. Okay, so we have to know about the types of source. As types of source, there are two types of source. First is independent source and second is dependent source. Dependent source, independent, ideal independent source. Okay, an ideal independent source is an active element that provides a specified voltage or current that is completely independent of other circuit element. Here are the example of uh, ideal voltage source element. It can be represent as like this, and this is ideal current element. It can be represent as like this. Okay, the second is ideal dependent or controlled source. An ideal dependent or control source is an active element which the source quantity is controlled by another voltage or current. Uh, this is a symbol which by which we can show the dependent uh, source. It may be dependent on voltage or current. In the next slide, types of ideal dependent or controlled source. Okay, here are four diagrams which represent ideal dependent controlled source. Let's first a voltage controlled voltage source. From this one is a voltage controlled voltage source. This voltage source controlled this voltage. Okay, and second one is a voltage controlled current source. By seeing this diagram, we can see that our voltage source is controlled by current. Our voltage source is controlled by current. And by seeing third one, a current controlled voltage source, a current control, this is current controlled voltage source, this is voltage. And fourth one is a current controlled current source. This one is current and this one is current. A current source which can be controlled by current. So there are four types of dependent source. Okay, let's do some problem which we have taught in previous lecture on that concept. Let's first problem is compute the power absorbed or supplied by each component of the circuit in figure. Okay, we have studied in previous lecture about the absorbing power element and delivering power element. Okay, as we mentioned previously that if there is voltage source like this, and current is going from this one. The power, we can write power as multiplication of voltage and current. It will be minus Vi. Mean this we can called it delivering power element. Okay, and when our current is entering to positive terminal of our voltage source, let's, it may be like this one, and the direction of current is this, then we can call it absorbing power element. This one is absorbing power element. Okay, so we have to find out in this circuit which element is delivering power and which element is absorbing power. Let's uh, do one by one. If we see this element in figure, it is mentioned as like P1, then we can write voltage across this one minus 5 volt and current entering to negative terminal of voltage source. Means by seeing this we can surely told that this one is delivering power. Okay, by seeing this one P2, we can surely say that this element is absorbing power element. We can write it P2 equals to 2 volt into 8 ampere, it will be 16 watt. Okay, by seeing this one P4, by seeing P4 we can write our current is entering at positive terminal of voltage. Means we can surely told that this element is absorbing power element, and the power across this one is 3 volt multiplied by 5 ampere, this will be 15 watt. And through this dependent source element, as we mentioned previously, and this one is current controlled voltage source element. So for P3, we can write it 0.6 I multiplied by 3. Okay, I we have to here I equals to, we have I equals to 5 ampere. Let's write it here, 6 into 5 multiplied by 3, this will be 9 watt. Okay, so we have delivering element, power delivering element is P1 and absorbing element is P1 plus P4 and P3. So as we see in previous lecture that in any circuit, in this closed circuit element, summation of power should be equals to 0. So we can check it here. If we add P1 plus, if we add P2 plus P4 and P3, then it will be equal to 16 plus 15 plus 9 watt, it will equals to 40 watt. And this, and so we can write it like P1 plus P2 plus P3 plus P4. We have P1 equals to minus 40 watt, and addition of P1 plus P2 plus P4, we have 40 watt, so it will be equals to 0 watt. Okay, go to the next one. So this problem, find the power absorbed by each element in figure. This one, from this one, we can surely say that current is entering to the positive terminal of voltage. So this element has nature of absorbing power, and absorb power will be equals to 4 into 10 equals to 40 watt. Okay, from this one we can say that this is delivering power nature, and this is delivering power. So we have P2 equals to minus 12 into 2, it will be equals to minus 24 watt. And by seeing this one, this current is entering to the negative terminal of voltage, so we can write it P3 equals to minus 5 volt and minus 3 ampere. It will be equals to 15 watt. We can say it is absorbing power, as we have negative current entering to the negative terminal of voltage. Okay. And in the second problem, figure shows a circuit with 5 elements. If P1 equals to minus 20 watt, P2 equals to 50 watt, P4 equals to 10 watt, and P5 equals to 40 watt, calculate the power received or delivered by element. So we have to do the summation P should be equals to 0. Okay, very simple. So means P1 equals to 20 watt, P2 equals to 50 watt, P3 equals, we have to find, and P4 equals to 10 watt, and P5 equals to 50 watt. So P1, P3 we have 100 watt. Okay, let's go to the next problem. In next problem, the problem is the current through an element is shown in figure. Determine the total charge that passed through the element at t equals to at 3 seconds. Okay, so we have to find charge at t equals to 3 seconds. So as we know that I equals to dq by dt, so we have to find charge here. Okay, we have to find charge here. If we integrate it from both sides, we have q equals to integration of I dt. So at t equals to 3, means we have to, if we can divide it in 3 regions, from 0 to 1, 1 to 2, and 2 to 3. So we can write as like from 0 to 1 we can write it 10 dt, plus from 1 to 2 let it is I t dt, and in third region from 2 to 3 it 5 dt. Okay, if we calculate it, it will be 10t plus it will be 5t plus we have to find it from 0 to I t dt. we put 0 to 1 and 1 to 2. Let find it. So if we see the coordinate of this one, it will be 1 comma 10, and coordinate of this one, it will be 2 comma 5. So we have to find it minus, as we familiar equation between 2 point y minus y1, y minus y1 10, y2 minus y1 upon x2, yani 2 minus y1, and means t minus x1 is x1, this one. Okay, it minus 10, this will be 5t minus 5 minus this. Okay, it will be minus 5t, this will be 15. Okay, so our it will be this one. Now we have to differentiate it. If we differentiate it, we can get 5. Okay, from 1 to sorry, we have to integrate. Okay, we have to integrate. If we integrate this one, we get minus of 5t square by 2 plus 15t, and our integration from 1 to 2. By putting this value of this will be equals to 10, and value of this will be equals to 5 common 2 minus 1, it will be 5, and by this, and from this let minus 5 common, 5 by 2 common, and it will be equals to 4 3. Okay, and by 15 1. Okay, it will be minus 15 by 2 plus 15, this minus 7.5, it will be equals to 7.5. so we have 10 from this one, we have 7.5 from second one, and we have 5 from third one. So if we add, we have 10, 7.5 plus 5, so we got it 22.5 coulomb. Okay, go to the next problem. This is question number 4. The charge entering a certain element is shown in figure. Find the current at t equals to 1 millisecond and t equals to 6 millisecond. Okay, at t equals to 1 millisecond and t equals to 6 millisecond. Let this one is 1 millisecond, and at 6 millisecond we have to find at 6 millisecond. Okay, so where we have qt, and as we know I equals to dq upon dt. So if we show this one symmetry, by symmetry, if this one is represent 80, this this one represent 40, so we have y we have uh, I equals to, at t equals to 1 millisecond, q equals to 40 divided by 1 t. Okay, so we can write it d 40 t upon dt. It will be equals to 40 at t equals to 1 millisecond. Okay, at t equals to, second one is b part, at t equals to 6 millisecond. Okay, at 6 millisecond we have q equals to 18. So if we go to differentiate this one, we can write I equals to d of 80 divided by dt. It will be equals to 0, means at t equals to 6 millisecond we have 0 charge, we have 0 current. Okay, sorry, we have 0 current. Okay, thank you.